Hello everyone. I completely messed up and didn't realize that there's a whole other section to Polynomials Lesson 1. So what we're going to do is continue on. This should be a short video, but this is still part of Lesson 1, unfortunately. I skipped over all the algebra tile stuff. We're not going to deal with algebra tiles this year. We just don't have a lot of time, and it's better to learn it generally so that you can apply those skills in a better way. So we are going to quickly look at the addition and subtraction of polynomial expressions. So in order to add and subtract polynomials, we need to know what like terms are. So like terms are the same variable raised to the same exponent. So for a good example here is 3a, 7a, and a. Those are all like terms because the exponent or the variable is a, and the exponent is 1. They all are variable a with an exponent of 1. Another good example is 2x to the power of 3, 1 over 5 times x to the power of 3, and negative 4x to the power of 3. Those are like terms because they are all variable x and they are all to the same power. If you have a different power, it's an unlike term. Or if you have a different variable, it's an unlike term. So for example, 2x to the power of 3 and 1 over 5x to the power 2 are different terms. They're not like terms because that exponent is different. One's a 3 and one's a 2. Another example is if you have a different variable completely, 4x and 4y, those are unlike terms. So you actually can't add them together. You can add and subtract like terms, but you cannot add or subtract unlike terms. So let's get into a couple of examples here. In this first one, we have two trinomials, 3a minus 4b plus c plus 3b plus 5c minus 3a. So you can see that we have some like terms here. 3a and negative 3a, those are like terms. So we can deal with that. So it's pretty much like saying 3a plus negative 3a. So that becomes 0a, or just 0. We don't have to actually write that term. Because if we have positive 3a's and we subtract 3a's, we have no a's left. The next one is negative 4b and positive 3b. So now we are going to say negative 4 plus 3 is going to be negative 1. So we have negative b. And then last but not least, we have positive 1c plus negative 5c's. So if we have positive 1, add negative 5, that's going to be negative 4c. And that's the final answer. We are adding those two polynomials together. The a terms cancel out because if you have 3 sheep and you take 3 sheep away, you have 0 sheep. Same thing with a's. We have negative 4b. We're going to add 3b, so now we have negative 1b. You don't have to write that 1 there. You can, but if you just have one of them, you can just write it as negative b. And then, of course, plus positive 1c plus negative 5c gives us negative 4c's. So we had to add the same variables, and they all had the same exponents. So they were all like terms, the 3a and the 4b and 3b, and then the c and the negative 5c. Here we've got it lined up really nicely. So you can see that the first term in both polynomials is x squared, so those are like terms. The second term is x to the power of 1, so those are like terms. And the third term are constants, so those are like terms as well. So 4x squared minus 2x squared. Well, if we have 4x squareds and we take away 2x squareds, we are left with 2x squared. Now, the next one's a little bit trickier to visualize because we have negative 9x's and we're going to subtract negative 3x's. So if you write it out, it's like negative 9 minus negative 3. And when you subtract a negative, you chop, and you make it a positive. So now it's like saying negative 9 plus 3 is negative 6. And those are x's. And last but not least, 6 minus negative 1. Well, again, it's minusing a negative, right? Positive 6 minus negative 1. When you subtract a negative, it's like adding. So 6 plus 1 is 7. We'll go over 2 more examples, and then the video should be done. So this is a really quick one. I just totally forgot to tack it on to the end of the lesson one there. I didn't even notice that this was here. So we have these long polynomials, and we want to simplify them. And you can see that between each term there's an addition or subtraction. So we want to add or subtract like terms. So we have to figure out where the like terms are. So it looks like I have an x term. Is there any other x to the power of 1 terms? There is, right there. So normally I like to, I wonder why that keeps doing that. Normally I like to underline or circle or box things just to make sure that I'm not forgetting about a term. So I have 4 x's, subtract 1x, that gives me 3x. Now let's go with the next one. I have negative 2x squared. Is there any other x squared term? Oh, right here it looks like I have negative 6x squared. So if I have negative 2x squareds and negative 6x squareds, together I have negative 8x squareds. And last but not least, I have a plus 3. So do I have any other constants here? Yes, I have a plus 5. 3 plus 5 is 8. And if you wanted to, you can rewrite this. This is the answer right here. You could rewrite that in descending order if you wanted to. So that means you're going to put the term with the largest exponent first. So negative 8x squared. And then the next one, that was an accident, plus 3x plus 8. And that would be the proper way to write that. All right. The next equation is a little bit long. So what we want to do is find all the like terms. It can be a little bit confusing. The first one is a squared b. So we can only combine that with any other term that is a squared and b. The next one is not a squared, not a squared, not a squared. This one's a squared plus b. So I have one a squared b term, and I'm going to add 5 more a squared b terms. So that means I'm left with, I'm going to do it down here, 6 a squared b terms. The next one I'm going to deal with is a b squared. So opposite now. A is the power of 1 and b is the power of 2. The next one is not an a b squared, but this one is an a b squared. So I have negative 1 ab squared, and I have negative 7 ab squared, so that means I have negative 8 ab squareds. And it looks like I have one more term right here, positive 4a3b, positive 4ab3. And so I can write this in descending order if I wanted to, and you can see here that this last term is a degree 4, this is a degree 3, and this is a degree 3. So that last term should actually go first. So we can write it as 4ab cubed plus 6a squared b minus 8ab squared. And that's your final answer. This one isn't wrong here, but if you wanted to clean it up and make it look nicer, it's nice to rearrange it so that the highest degree goes first. Cool. Sorry about that. Hopefully it's not too confusing on the Google Classroom, and I'll talk to you guys later.